Okay, we're going to have a little tutorial on how to simplify and solve compound circuits, also known as complex circuits. Here is a little circuit. We have 60 volts, we have two branches, we have one branch right here, and that splits off with another branch down here. So we have little series circuits on this branch, and then we have a series joined with some parallel circuits. Now if we want to solve this and understand what's going on with the flow of the different currents through these different resistors, we want to break this down into simpler and simpler circuits. We're going to start by combining the 8 ohm and the 8 ohm resistor and combine that into an equivalent resistance. Now, we know that the rule for equivalent resistances with a parallel circuit, if we say 1 over Req is equal to 1 over R1 plus 1 over R2. So we could solve that by saying, all right, 1 over Req is going to be equal to 1 over 8 plus 1 over 8, which is 2 over 8, or 1 over 4. And therefore, Req is going to be the inverse of 1 over 4, which is 4. Okay? Now, here's a little trick. There's a simple way to combine two parallel resistors by having this fun little formula, which says that Req for a parallel, I'll put a little parallel, is going to be equal to R1 times R2 over R1 plus R2. Now that expression is the same as this. It's just an algebraic simplification, and it only works if you just have two resistors. So let's check to see if this works for our particular example. So that's going to be 8 and 8. We've got 8 times 8, which is 64, divided by R1 plus R2, which was 16. So 64 divided by 16 is equal to 4 ohms. So it works. Okay, good. So now we're going to combine those two 8s into one 4, and we're going to get a new circuit that looks like this. A little bit simpler. We have a 16 and a 4 now instead of a 16 and two 8s. Now let's go ahead and combine these two and those two, since those are in series, and bring those together, and they're going to look like this. 10 and a 10 gives you 20. 16 and a 4 gives you 20. Now we've got these two 20s that are in parallel, so remember we're going to go 20 times 20 divided by 20 plus 20, or 40. So we get 400 over 40, which is 10. So the simplest circuit is going to look like this: 60 volts with the 10 ohm resistor. We call that the equivalent circuit. Now, with the equivalent circuit, we can now figure out what is the current going through this circuit, or what is the current going through the battery. Right? Now, V equals IR, so I equals V over R, which is, the voltage here is 60 volts, and the resistance is 10 ohms. So the current is going to be 6.0 amps. Okay? So we have 6.0 amps going there, which means that if you look back at this circuit, you have 6.0, that doesn't look very neat, does it? 6.0, wow, come on, O amps going through there, and 6.0 amps through this version, etc. Now notice, when you have your 6.0 amps coming through here, and then this branch and that branch are each 20 ohms, well then you can predict that means that 3 amps are going to go this way. And that means 3 amps are going to go this way. Because if you had 6 total and half's going to go one way, half's going to go the other. Now let's just verify that makes sense, because we had a total of 60 volts, right? And 20 ohms. So what is the current going to be? 60 volts, because there's a 60 volt drop across here, right? Because that's a parallel circuit, so 60 volts. So 60 volts divided by the resistance 20 ohms gives you 3 amps, which is what we found by symmetry anyway. So there you go. So now we can figure out what current is going through each of these. So now we have 3 amps going through here, through there, and then we're going to have another 3 amps going through there. But what's going to happen when the current breaks up? Right? We're going to have it split. Half is going to go through the 8 ohm, half is going to go through the other 8 ohm, for a total of 1.5 amps going through the 8 ohm, 1.5 going through the other 8 ohm. just for fun, let's figure out what the voltage drop is across each of those. And I'm going to put these in orange. So across this 10 ohm resistor, remember the voltage drop, V equals IR. Can't seem to write on this thing right now. IR. Okay, forget it. It's not writing. V equals IR. So the voltage is going to be, the current is 3 amps. The resistance is 10 ohms for a total of 30 volts. So we're going to get a 30 volt drop across that particular resistor. And we're going to get another 30 volts across this resistor for a total of 60 volts. Because in that pathway, you go up 60 volts and then you go down 60 volts. What about down here? Down here we have 3 amps through the 16 ohm for a total of, well, remember it's V equals IR. 3 times 16 is going to be 48 volts. And then if you went through this branch, you have 1.5 amps times 8 ohms. So you have 8 ohms times 1.5 for a total of 12 volts. So again, if you were to travel, I'm going to put this in green now. Green. It's getting messy now, but try to follow along. If you go through this branch, you're going to go drop 48 volts here, drop 12 volts there, and then go back home. So you go up 60 volts and then you drop 60 volts. Any route you take across your circuit, you're going to have a total voltage drop is going to equal whatever your voltage increase is. Okay, so that's kind of messy, but gets you the idea. So here we are. If it goes to this question, it says, so what is the current going through each of the pair of 10 ohm resistors? So that means through here and through here. Well, remember we figured out that it was 3 amps going through each of those. What about each of the 8 ohm resistors? Well, remember we had 3 amps going through here, and that split into 1.5 there, and 1.5 there. Okay, let's move on to another circuit. Okay, here's another circuit. It has kind of a lot going on. We have a little 6 ohm, and then we have a parallel branch where it breaks off into 2 separate parallel circuits with a 4 and a 2 series in one of them. We want to combine this into a really simple circuit and then try to solve to figure out what's the current going through each of the resistors and what is the voltage as well. So I'm going to start by clearing off some space here. So now we have some space to work with, and I sketch a simplified circuit. Now notice that this circuit that I have just sketched, it has the 6, it has the 12, but then I took this 4 and this 2, and I combined them, because they're in series, to form a 6. Okay, so that's my first simplification of the circuit. Now I want to combine again. So when I combine it, the next simplified circuit, I'm going to combine my 12 with my 6. Those are 2 in parallel. So remember 12 and 6 is going to be 12 times 6, which is 72, divided by 12 plus 6, which is 18. And so I will get a total of 4. Okay, so now I have a 6 and a 4, and those are in series. So one last step, I can combine those to get a 20 and a 10. Okay, now that's going to give me what I know is going to be my total current through the entire circuit, which is going to be 2 amps. So I make my little table of values. I can keep track as I work my way through. I'm going to erase this so I have a nice clean area to work with. Okay, so what I now know is my total voltage is going to be 20 volts, and my equivalent resistance is 10, which means my total current working through this circuit is going to be 2 amps. Okay, now I want to figure out what's going to be going on with the other circuits. So I know that I have 2 amps going through the main circuit and going through that very first resistors. Now what I'm going to do is keep track in my little table and write down all of the different resistances that I have to figure out. Okay, so hold on, let me erase that a little bit. So what I know is that I've got a 10, I've got, well 10 is my overall. I've got the 6 ohm, the 12 ohm, the 4 ohm, and the 2 ohm, and I want to find out what is the voltage and current through each of those guys. Now, I know I have 2 amps going through the 6 ohm. So that's the first one I'm going to focus on, because if I have 2 amps going through there, then I know that the voltage drop across that circuit, that particular resistor, is 12 ohms. I'm sorry, the resistance is 6, the voltage drop is 12 volts. Okay, so I can sketch on my thing, I've got 12 volts drop right there. Well, if I have 20 volts altogether, and I just spent 12 of them getting through the first resistor, well, what do I have left for the other pathway? Well, it turns out that I'm going to go to my simple circuit up here on the upper left. If I have 12 volts across the first, that's going to leave me with 20 volts minus 12, which is 8 volts to get across the other 2 branches, whichever way I want to do that. Okay, so now I can go and put on my little table, on my 12 volt, I have 8 volts, I'm sorry, 12 ohm, I have 8 volts across that one. So now I can find the current to the 12 ohm resistor, which is basically 8 divided by 12, or 0.67. Now I know that I also have, well, let's keep track of our currents. Okay, I'm going to erase again to try to keep it simple and clean. Okay, I know that I have 0.67 amps coming through that first branch. If I had 2 amps going in, because these 2 amps here are also going to be going here, 2 amps coming in, then if 0.67 goes down, then that means I have to have whatever's left over to go out the other end, or 1.33. So now I know the current that's going through the 4 and the 2. So I can add it into my little table, 1.33, and now I can find the voltage drop across each one. V equals IR, and so I just multiply those in order to find those. Now, if I work my way around any particular circuit loop, I should find that the total voltage drop is going to be 20 volts. So I got 12 volts on the first one, and if I go through that 12 ohm resistor, then I know I've got 8 volts, so that drops 8 for a total of 20. Or if I go through the other branch, 12 volts from the 6, and then 5.3 of the 4, and 2.6 from the 2, for a total of 20. So whatever route I take, whatever voltage increase I have from my battery, I should lose through each of the resistors. Okay, and that concludes our tutorial.